Going on to topic 6 of chapter 1. As I mentioned before, this is a review of basic algebra, and lots of stuff included here in this first chapter. In this section, we're going on to first-degree equations. These may be called linear equations because the variables in the equations, because of the equal sign, are only to the first power. And these, as I see, are only using one letter. Now, other equations where the exponents are greater than 1, as we see here, this is x to the second, and also when you have variables under the radical sign. Okay, these are not straight line equations. Now, the solution of an equation is a number that can be substituted for the variable in the equation to produce a true statement. For example, substituting the number 9 for x in this equation, 2 times 9 is 18 plus 1, makes this a true statement. So we say 9 is the solution for this replacement of the letter in this equation. So let's look at some of the properties of equations. Now, I've used this analogy before, in which we have a board of some type, a little fulcrum, and a weight on one side and a weight on the other. And this is balancing. We're saying, in a sense, that this side equals this side. Now, if I take away something from this side, and the same amount, may not be getting exactly the same amount, but in theory it's the same amount. Now, what is on this scale or this board is not the same anymore, but it still balances, it's still equal. Well, this is the principle that we use for properties of equalities, that eventually we want to have, let's say on one side, an x, and on the other side this will be a number like 3. So the series of steps that we do to equations to eventually isolate one letter on this side equals a certain amount on this side, we call these series of steps solving an equation. And here they're indicating that if A equals B, if we add a C to both sides, it's still equal. It's not the same, but still equal. Or if we subtract the C from both sides, it's still the same. And that's true if we multiply or divide both sides by the same non-zero number. So let's look at some examples here. Here's a very simple equation, and I'll write it out over here as well. 5x minus 3 equals 12. Now, we had mentioned earlier in this series of lectures that if we take the opposite of a negative 3, which is a positive 3, that makes this a 0. But again, to keep it equal, we have to take that 3 and add it to both sides. So we have also suggested that you can take a term from one side, transpose it to the other side. Here it becomes a positive 3, and you then get 5x equals 15. And then to isolate the x, we would divide by the numerical coefficient, which is 5, and we get x equals 3. And if we put 3 in the original equation, it makes it a true statement. So we say that x is a solution for this particular equation. And what we are quickly going to do here is to get in more and more difficult equations. Here, one of the rules is to get rid of grouping symbols. So we have to distribute this, being careful of the signs. And then once we do that, we group like terms, and we end up with something like this. Then again, we want to get all of the k's, the variables, to one side. So we would transpose that. That would give us a 3k. Transpose this. Again, a negative 12 on this side becomes a positive 12. So this gives us a 6. And again, we divide by the numerical coefficient. K equals 2. So depending on your level of skill in solving equations, you're going to include more steps. Again, you want to develop a protocol to get it correct, and there are slightly different ways to do it. Now, when you get something like this, they're giving you a word problem, and we're not going to read it completely, but this is the equation that comes out of it. And we see there's an x buried in there, and we want to find out what that x is. So, again, the series of steps. I would have gotten rid of the decimals, but I see they're not doing that here. And again, isolating the x, eventually solving for it, and then using your calculator, of course, to add all these together and find a value for x. I'll spend a little time on this one because this is a very, very useful technique. Now, I've copied the original problem. They're going to solve it in a similar way, but I'll do it here for you. So there is your original example in red, and what we want to do here is to get rid of our fractions. Now we're going to do this by changing the equation, making it in a sense larger, but still equivalent, so the values of r don't change. And we do so by looking at our fractions and seeing what is my least common denominator of a 10, a 15, a 20, and a 5. And it turns out to be 60. So what I'm going to do is multiply each term by 60. Now, it's important that you multiply each term by 60. And that's what they're showing here. Now, we cancel the 10 with the 60, and we get a 6. The 15 with a 60, and we're going to get a 4. 20 and 60, and we get a 3. 5 with a 60, and we get a 12. Didn't come out too well, but let's move to our next step. Now, we don't have fractions anymore, but we need to complete our top process. So we get 6r here. Now there's a minus. 4 times 2 is -8. 3 times 3r is 9r. And then here we get a 12 times 1 is 12. So again, looking at the original and comparing it to what we have now, it's much easier to solve. We want to keep our r's, our variables, positive. So I'm going to subtract 6r, or transpose it, and then here we get a 3r. Transpose this to this side, it becomes a positive 12, so this becomes a 4. We then divide both sides by 3. We get r equals 4/3, and that's what they have. Okay, now if you put 4/3, again, it would be difficult doing it in the original form, but if you did it in one of these forms, you would see that yes, that is in fact an equation and a solution for the equation. Alright. Now in this next example, they're going to show us that from time to time we may get a solution for a variable that when we put it in the denominator, if there is a variable in the denominator and that solution makes the denominator a 0, then we say that is not a solution. We only can have what we call up here non-zero producing solutions. Otherwise, these are considered extraneous solutions. That is, it doesn't make it a true statement. Okay, well, let's take a look at this one, because this is a higher level getting rid of our fractions, and I'll set it up here for you. So as we look at this equation, we need to get rid of the fractions. So what is our lowest common denominator here? Well, we're going to need a 3, and we're going to need a k plus 2. So another way to do that is just to put a big set of brackets like that and put your lowest common denominator out here. Now you could put it by each term if you want, but this is another way. They're showing you that way. So here, as you multiply this by this, all of this cancels out, and we just get a 4, which is very nice. All of this cancels out with this, and we just get a negative k. Now here, just the 3 cancels out, and we have to take the 5 and multiply it by this, which gives us 5k plus 10. So that's a lot easier. We transpose the k. On this side it becomes a plus, so that's 6k. Transpose this 10, becomes a negative 10 on this side, which gives us a negative 6. We divide both sides by 6. We get k equals a negative 1. Now, they are saying if we put a negative 1 in there, doesn't make any of our denominators a 0, so that's good. This, then, is the solution. In example 6, we see we have a fraction. It's the same, so we're going to multiply each term by this fraction. Here it cancels out, here it cancels out, so we end up with 3x minus 4 equals x. We then transpose the x to this side, becomes a 2x. Transpose the negative 4 to that side, becomes a positive 4. Divide both sides by 2, we get x equals 2. But once you do that, and you put 2 into your original equation, what are my denominators here? Your denominators become a 0, or at least if only one of them becomes a 0, then x cannot be 2. So we say this is an extraneous solution. And we say this particular equation has no solution. All right, let's go on. Now, you can always go back and look at your textbook that you have as an ebook. That's where I got this from. Or you can pause and rewind the tape as needed to look at something in more detail. Now, here's a case where there are 2 letters in there. There's an A and an X. There's another. There's a B. So there are 3 letters, but we want to solve this equation for the letter X. So how do we do it? Well, again, it's the same techniques. We want to isolate the X term. So we distribute here, and we get this. Now notice we have an X in this term, and an X in this term. So we're going to transpose this term to the other side. It becomes a negative 4x. And we're going to take this term and this term and transpose it to that side. And this is what it looks like now. Now notice we have an x in 2 terms. Well, what we need to do is factor that x out. I would have put it over here, but they put it there. That's fine. And now we're going to divide both sides by this. And that's what you see they've done. So this cancels out on this side, and we get x equals that. Okay, now another type of equation is one in which we have an absolute value. Now we didn't do this in our earlier course, so here it is. And it's just a little extra step. Much of it is the same. The thing we have to keep in mind that if we have the absolute value of 4 that we say is 4, or the absolute value of negative 4 that we say is 4, that there could have been a positive value there, or there could have been a negative value there. And that's basically what we do here. So in solving this, we're going to say we take away the absolute sign, and we say x equals 3, taking away the absolute sign, or x could have equaled, and we just change the sign, a negative 3. And that's the solution for example 8. And the strategy, again, take away the absolute sign, equal it to whatever is there, take away the absolute sign, but then this item on the other side has the opposite value. Okay? Now there's one little tricky thing that you'll run into every once in a while, and they'll say the absolute value of x equals a -3. Well, by definition, the absolute value of something has to be positive. So if it starts off looking like this, there is no solution for that. All right, let's look at some other examples here. And it's done a similar way. We take away the absolute sign, p minus 4 equals 2, or take away the absolute sign, p minus 4 equals a -2. So we're just taking away the absolute sign, writing it the normal way. Take away the absolute sign, and then what's on this side, we reverse the sign. And then we solve this. So here this is p, transpose that equals 6. Here p, transpose that becomes a positive 4 equals 2. So there are your answers, 6 and 2. And that's the procedure for doing it. For this one, we can use what's in our textbook. Here, the absolute value equals an absolute value. So the first one would be just remove the absolute signs, which is what they've done, and you solve for m. m is 3. Now, the next time you're removing both absolute signs, but over here, you have to put this right side into parentheses and change the sign. So then what's inside the parenthesis, both of these change their sign. So this becomes a -m, this becomes a -6. This step is crucial, so you're sure not to change, or you are to change both sides, both signs. Then again, solve. Transpose becomes a 5m. Transpose, this now becomes a -3. m, your other value is this. Okay. Now the next part is taking English in word problems, converting it to algebra, and solving them. Now there are a series of steps that you should follow. They're written down, and read it carefully, trying to find a variable that will make sense. Going through all of this, make a sketch or a chart, then putting it into an equation, solve the equation, check. Okay, these vary from textbook to textbook a little bit. Usually it's 5 steps, but here I see there's 7. That's okay. All right, let's look at example 11 here. I should probably pause the tape and read it. So someone has $15,000 to invest. They're going to invest some at 5% and some at 8%, and they want to earn this much per year in interest. How much should they invest at each rate? So this is classical, where you have a certain amount and you want to divide that amount into 2 parts, and you don't know how much each part is. This is the beauty of algebra. You can say one part is x, and then the other part is 15,000 minus that x. So if you were to add these together, you get 15,000. That's what's in this box. Just dividing it into 2 parts to get the algebra to work its magic. Now we could say this part here is the change colors here. 5%. And you can say this amount here will be the 8%. So you start to set up equation. 5% of this portion of it plus 8% of the other portion will earn you this much money. Now I'm putting 2 dots there, 2 decimal places, so I can do what I want to do, get rid of all my decimals by multiplying each term by 100. And that's my new equation. So I will work this for you. So this is 5x. Multiplying 8 times this, I get 120,000. 8 times the negative x is a negative 8x equals 102,000. Then I group like terms. I get a negative 3x. Subtract this from both sides. I get a negative 18,000. Divide both sides by a negative 3. I get x equals 6,000. Now if you recall, x was our 5%. So this is going to be 6,000 here. And I had 15,000 to invest. So this will be 9,000. And that's what they'll ask you. What did you invest at 5%? What did you invest at 8%? And again, in your homework log, you're making this neat so that you can follow it as you do your examples. And here they lay it out for you, which is what I did. And there are your answers. Okay? All right, now we're going on to example 12. We'll have to read it. In looking over example 12, again, it's rather tedious and it would take a long time for me to read it to you. You must read it yourself. They do give you the steps item by item, and they take it as through the steps mentioned earlier. They suggest in this case using a chart to organize your data, and then eventually you end up with this equation. When you solve for x, you find that x is approximately this. Now this is always sort of a pain in the neck here when you put it into MATLAB, when you're getting approximate answers and you don't round off the way they want you to do it. Normally on a blue paper test, I would give partial credit or full credit if it's just a rounding off error, because you've mastered all of this technique in putting together an equation and getting close to the answer. But again, that's up to your particular teacher as to what they will be doing. Okay, let's take a look at this one. Again, you need to pause the tape or read it carefully in your textbook. The procedure for solving it is all laid out here, and it takes a lot of reading and organization, and this is something that is just time consuming to master. Again, if you have a 100,000 gallon mixture, and you want to divide that into two parts. Remember, part of it is X, and the other part is 100,000 minus X. And then this is the total amount of the mixture. And there is your equation down here. This is a typical mixture problem. It's just tedious in that there's so much words, and again, when you are approximating, you need to be careful and follow the directions carefully. Don't round off until the very, very end. And that will wind up topic 1.6.